Hi everyone, my name is Bethany. I'm from the University of California, Santa Barbara, and I'll be speaking a little bit today about contrastive pitch accenting in the visual world paradigm. So the primary measure of prosody that I study is pitch accenting, which describes various changes of fundamental frequency, typically within a syllable. Generally, pitch accents provide prosodic cues for prominence within a sentence. So within conversation, they can be used to introduce items, clarify ambiguity, or focus the conversation on a specific discourse item. In this case, we'll be looking at contrastive prosody, so specifically pitch accents which highlight contrast between two items in a pair. In the current study, we manipulated stimuli to hit either a presentational or contrastive accent. So in the Toby system for prosodic transcription, this would be classified as H star and L plus H star. However, this study doesn't really depend on any particular system of transcription, so I'll continue to refer to these accents as presentational and contrastive. These accents differ acoustically in that presentational accents hit a high pitch. So for instance, what pet does Jennifer have? Jennifer has a cat. And then while contrastive accents scoop from a low to high pitch and they differentiate between two references. So for instance, does Jennifer have a rabbit? No, Jennifer has a cat. So it kind of scoops up there at the end. In the current study, we'll be using contrastive pairs within short narratives. So here the context section of a narrative might be, although Jennifer owned both a cat and a rabbit, the two pets got along great with each other. There wasn't a problem until her cousin visited and brought along her ferret and bird. Then the continuation section of that narrative might be, Jennifer's rabbit hated the cousin's ferret, and chaos broke out in the house. So here we'd be choosing a word from each of the contrastive pairs to fit into word slots, is what we're calling them, of the continuation. And so we'd be placing a contrastive pitch accent on one of them. Placing a contrastive pitch accent on rabbit is intended to provide the most prominent contrastive distinction between rabbit and cat versus any distinctions between the non-contrastively accented ferret and bird. Along with enhancing prosodic prominence and contrast, contrastive pitch accents have also been shown to affect information processing and cognition. So in 2008, Ulmer and Imus observed that contrastive accents placed items in focus and that participants exhibited improved reaction times and comprehension abilities as well. Meanwhile, participants in Sanford et al. 2006 experienced improved memory for contrastively accented stimuli. And then this occurs even in other languages. Contrastive pitch accents have been shown to benefit processing in L1 speakers. Braun and Tagliapietra in 2010 noted that contrastive accenting of primes drove recognition of contrastive associates in Dutch. So here, they listened to sentences, completed an LDT for various types of words, and then if the participant heard this auditory sentence and then saw the contrastive associate pelican, pelican would be facilitated only when flamingo was contrastively accented. So previous literature here has demonstrated some effects of contrastive pitch accents on various processing and cognitive abilities, from reaction time to memory to facilitation of contrastive associates in lexical decision tasks. And then this experiment recorded the effects of contrastive pitch accenting on recognition memory, which is the ability to recognize a previously encountered stimulus as familiar. Past studies have observed that contrastive prosody heightens recognition memory orally through verbal emphasis, over text through italics and capitalization, and then visually when speech is paired with gestural indications. Fraundorf et al. Conducted a 2010 study to explore the role of contrastive pitch accenting in memory for short narratives. We'll be focusing on experiment 1 since that's the one most relevant to the current study. In this experiment, participants completed a listening phase and a test phase. In the listening phase, they heard audio narratives that introduced two contrastive pairs before specifying one word in each contrastive pair in the two word slots, as I mentioned earlier. For instance, they might hear, both the British and the French biologists had been searching Malaysia and Indonesia for the endangered monkeys. Finally, the British spotted one of the monkeys in Indonesia and planted a radio tag on it. And then here, the contrastive pairs were British and French, Malaysia and Indonesia, and the specified words would be British and Indonesia, where British received a presentational pitch accent and Indonesia received a contrastive pitch accent. Trials that included both a presentational and contrastive accent, like I just mentioned, would be used as critical, while filler trials included two presentationally accented words instead. And then in the test phase, participants saw the critical narratives represented visually, and they were asked to fill in the 2 specified words from the contrastive pairs. So for instance, they would see British and French on the screen. They would click a key to fill in the correct word, British, for instance, by pressing a key on their keyboard, and so on. And then results from experiment 1 of Fraundorf et al. 2010 suggested that participants experienced better recognition memory for contrastively accented items in pairs. So Fraundorf et al. Thus suggested that contrastive pitch accents must either help people to remember a contrastively accented word or perhaps inhibit their memory for the other word in a contrastive pair. And then these conclusions would be based in past literature. They're known as the granularity and contrast representation accounts of contrastive pitch accenting. The granularity account proposes that listeners would encode contrastively accented words in a more specific manner. So here, perhaps amplifying the memory for Indonesia when it's contrastively accented. And then the contrast representation account, on the other hand, proposes that listeners' memories for competing words in a contrastive pair is inhibited when one word is contrastively accented. So here, like decreasing the prominence of Malaysia when Indonesia is contrastively accented. Further experimentation in the 2010 piece supports the contrast representation account, but more work is needed to draw conclusions on this front more definitely. So the current study is a replication extension of Fraundorf et al.'s 2010 piece. It aims to confirm the role of pitch accents in recognition memory and clarify the difference in how contrastively and presentationally accented words are processed. So to do this, we used the same audio stimuli as the original experiment, but we incorporated a visual world paradigm. 240 visual stimuli, which I drew, and eye tracking equipment were added for this extension. Eye tracking within a visual world paradigm would allow our study to not only quantify attention in a more temporally sensitive manner through fixations, eye movements, etc., but more specifically, as opposed to some other methods, to show causal links with visual attention. So to recap, in terms of replication, we wanted to know if memory for contrastive accents was still benefited in a new group of participants. And then to extend these results, we also looked at eye fixations during the learning and recalling of information with contrastive prosodic cues to see the influence of visual stimuli on encoding. We hypothesized that the study would generalize to a new group of people. Participants would look at and remember contrastive accented words at increased rates. And then we also believe that visual stimuli would benefit the encoding process. The current study was conducted in 3 phases. We had a listening phase where participants listened to stories and looked at corresponding images, a test phase where they completed a forced choice recognition memory test, and then the listening test phase were they both included an eye tracking component. And then the experiment concluded with a labeling phase where participants confirmed that they had accurately encoded image labels. This was meant to ensure that any particular trial or item wasn't harder to encode than the others. However, participants gave adequate answers on nearly all trials in this section, so all trials were included in our analysis. Participants included 32 native or native-like English speakers between the ages of 18 and 35. All were students at UCSB, and they self-reported that they could hear and see well enough to complete the study. So first, there's a couple logistic notes about each phase before I take you through a sample trial. These phases are modeled off of Fraundorf et al.'s procedure, which I went through earlier. The listening phase contained 40 trials, 20 critical and 20 filler, where participants looked at a visual world paradigm and listened to short narratives. Critical trials included, as I mentioned earlier, 1 presentational accent and 1 contrastive accent in the 2 ending word slots, where filler trials included only the presentational accents. And then we also included labels with the visual representations of words from the contrastive pairs. Trial order here was randomized, as was the picture placement in the visual world paradigm grid, which words were selected from the contrastive pairs, and the placement of the contrastively accented word in critical trials between word slots. And then item conditions were also counterbalanced across participants. And then the test phase contained 40 trials, presented in the same order as the listening phase. Narratives here were presented visually, and then participants completed a forced choice recognition memory test to fill in each blank, as was the case in Fraundorf et al. 2010. So for instance, in a sample trial, you might hear, Although Jennifer owned both a cat and a rabbit, the two pets got along great with each other. There wasn't a problem until her cousin visited and brought along her ferret and bird. Jennifer's rabbit hated the cousin's ferret, and chaos broke out in the house. Obviously, the words wouldn't be on the screen, but just for ease of reading. And then here, rabbit was selected over cat in word slot 1, and it received a contrastive accent. So we had rabbit, while ferret was selected over bird in word slot 2 and received a presentational accent. As mentioned, other participants would hear random variations of this contrastive pair, so perhaps cat and ferret, rabbit and bird, and so on. And then an example trial of the test phase might look like this. Here, the participant might read the narrative and decide that they want to choose rabbit for the first word slot. So they'd press F, see a little highlight in red to indicate that they filled in the first word slot, and then they might fill in word slot 2 with ferret, and now that would be highlighted in blue as well, and that would be the end of one test trial. And they do that about 40 times. And so as for what people remember, we conducted a generalized linear mixed effects model on this data. When examining the main effect of word slot on recognition memory, results suggest that items in the first word slot were remembered more accurately regardless of accent condition. So see the left versus right side of this bar graph for that comparison. We also noted that filler trials were remembered surprisingly well, but that the recognition memory scores in this study were actually lower on average than Fraundorf et al.'s study in 2010, and I will touch on this a little bit later. Next, we're going to look at the main effect of contrastive pitch accenting. So if you look at the graph here, each of these panels represents a contrastive condition. So on the very far, I guess that's your right, the two pink bars would represent recognition memory accuracy for both presentationally accented words in word slot 1 and 2 of filler trials. And then critical trials could fit one of two contrastive conditions. So either with a contrastively accented word in the first word slot and a presentationally accented word in the second word slot, or vice versa. So we'd need to look at opposite colored bars to compare memory for the different accents in word slots across stimuli. So to break it down, you can see that overall contrastive accents are remembered better than presentational accents in word slot 1 of critical trials. And then they are also remembered better than presentational accents in word slot 2 of critical trials. So on average, contrastive accents prompt slightly better recognition memory in critical trials than presentational pitch accents, and then this suggests possibly facilitation of contrastively accented words compared with their alternative. However, this effect is carried by an interaction effect between word slot 1 and contrastive pitch accenting. So to delve into this a little further, let's observe recognition memory within trials when a contrastive pitch accent is present in word slot 1. Given the significant drop in recognition memory here between the contrastive and presentational pitch accents, it seems like there might actually be some impairment of the presentational pitch items when an earlier item in the narrative is contrastively accented. And I'll get into this in a little bit later in my discussion as well. We also assessed the points in time during which participants encoded critical stimuli using spaghetti plots. So eye fixations throughout a trial are represented on these graphs. A contrastive accent was present in word slot 1 on the leftmost graph, and then it was present in word slot 2 in the rightmost graph. And then the two vertical lines track the onset of word slot 1 and word slot 2 in each condition. The bright purple peaks here, so the lightest purple, suggest that contrastive accents are fixated on more than all other options when encoding information, and the leftmost graph suggests that this trend is most apparent when the contrastive pitch accents are present in the first word slot. It is also notable that there's a delay between the word's onset and the peak of participant fixations on the corresponding image, and then we're going to talk a little bit more about the delay and more complex audiovisual processing, which I'll get back to in my discussion again. Lastly, this scatter matrix displays performance on the recognition memory test as predicted by the amount of time spent encoding a contrastively accented item in the listening phase. And then once again, we found that the more time spent encoding an item, especially in the first word slot, the better the recognition memory accuracy for said item. And now discussion. Before we discuss our results, let's go over my hypotheses again. So we hypothesized that this study would generalize to a new group of people and that participants would look at and remember contrastive accents at increased rates. We also believed that visual stimuli would benefit the encoding process. Contrastive accents do seem to benefit memory overall, which replicates the results of Fraundorf et al. Furthermore, these results are bolstered by our extension through eye tracking data. Not only do participants fixate most often on visuals associated with the contrastive pitch accents, especially in the first word slot, but also duration of item encoding time is indicative of better performance in the test phase, once again, especially in word slot 1. It's also interesting to note that the presence of contrastive pitch accents in word slot 1 seemed to specifically impair presentationally accented words in word slot 2. While the contrast representation account of contrastive pitch accenting is actually only targeted to explain why contrastive accents might impair memory for contrastive alternatives, future research might explore similar impairment-based theories that consider the broader sentence context in which contrastive pitch accents are present. And then our study also observed a main effect of word slot. Items presented earlier in the continuation sentence were remembered more accurately than those presented later in the continuation sentence. And then an interaction effect was also observed, where participants remembered items best when they were contrastively accented and presented in word slot 1. In comparison, Fraundorf et al. Did not observe this effect. In addition, the current study observed worse recognition memory for items overall, with a 78% recall accuracy in our study versus Fraundorf et al.'s 84% recall accuracy rate. However, Fraundorf et al. Only used audio stimuli in their experiment, and audio-only processing tends to take up less cognitive resources, so the addition of visuals may have slowed processing, which is suggested as well by the delay in fixation on in-focus items. Participants likely took in more complex stimuli more slowly, which might explain the primacy bias and the less accurate recall in the current study. And so, final thoughts. Since memory for our study, specifically in word slot 2, was worse than it was in the 2010 study by Fraundorf et al., future work might examine the extent to which audiovisual processing might slow and perhaps impair encoding. We also might look into the impairment of recognition memory within a sentence, so maybe either clarifying if the contrast representation account actually does play a role in impairing alternatives to contrastively accented items, or proposing further theories for why presentationally accented items in word slot 2 are recalled at a much lower rate when contrastively accented items are present in word slot 1. Future research might expand on past work regarding the modality of emphasis or accenting too, perhaps using capital letters in text or hand gestures, facial expressions, etc. We might observe whether this effect occurs differently in conversational versus lab context as well. And then lastly, past studies have also noted that contrastive accent effects are not reliable in low to mid proficiency second language English speakers. So I'm actually currently working on a follow-up to this experiment in Cantonese L1 speakers, which will demonstrate the effects of contrastive prosody on processing and recall in native speakers of tonal languages. Thank you to my faculty advisor, to Dr. Fraundorf for his collaboration and stimuli, and to everyone here for attending and listening. On an unrelated note, if anyone wants to contact me about a job while I look for PhD positions, my mentor put me up to this. And then lastly, we're excited. Thank you.
We have 11 minutes for questions.
Hi, thank you. I'm Sarah Lee from Penn. I was just wondering if you found any differences in your eye tracking data for the competitor in your contrastive accent versus presentational accent contexts?
Yeah, actually, so personally, what we've looked at mainly is the difference between the answers. Honestly, when we were looking at the competitors, we don't notice any significant eye tracking trends. I mean, in terms of recognition memory, all items, if they are fixated on more, lead to higher recognition memory, whether that is the competitor or the contrastive accented words. However, in terms of eye tracking data, there were no significant effects of people looking at competing items, whether they were the competing items like alternatives or just miscellaneous items like the two distractor items in our grid.
Yeah, thank you.
No problem.
Hi, Chigu Sakurumada, University of Rochester. This is super cool. I'm curious about the flip between the two, depending on the position 1 and position 2, right? In just clarification question, so the x-axis is 2,500, is this millisecond?
Yes.
Okay, so it's really slow in both
Yes.
conditions. Okay, that was my first question, and then I'm
yeah.
curious why it's so slow. The second question is, it's not only that the contrastive accent, the proportion of fixation to the object is decreased, it's much, much slower in position 2, right? Do you have any thoughts or explanations?
Yeah, so something I was thinking about here was, so first of all, there is like the delay in audiovisual processing, like I mentioned, but also it might just be because the sentences ended rather abruptly, and also some sentences did have longer continuation and context. So right now, actually, something that I'm doing with my data is doing further analyses on whether the length of time between like the different, the onsets of word slot 1 and word slot 2 will impact whether people, or will impact the presentation of items on this graph. So far, it seems like the averages are still constant, but yeah, as of now, I think that it is mainly just due to the audio-visual processing differences.
And then I just have this vague thought. So when you have pictures on the screen, right? So as soon as you start hearing the first reference, you can already kind of resolving the contrast because you see other things on the same screen too, right? So that's going to be another major difference between your paradigm and Scott's paradigm, right? So that not only is it more difficult to do multiple things at the same time, having candidate references in front of you might change the way you process the contrastive prosody. So that might be something to think about.
Yeah.
Thanks.
Hi, Helen, how you see? So I'm wondering, like, why do you think that contrastivity accented words are held better in memory? Is it because of its like accent is like less frequent, or is it because of its semantic status? And like relatedly, there are languages that convey contrastivity via like explicit morpheme marking. Like, would you expect the same results in those type of languages, like without any accent marking?
Right, so actually that's something that I'm looking at currently. Me and some of my other like undergrad lab mates are doing acoustic analysis on the stimuli to see whether it's just the prominence of the accent that's causing the recognition memory versus like it having like a contrastive, like insinuating that an item is contrastive. So people remembering an item just because it sounds louder or sounds different type thing. And so far what we've been looking at, it doesn't seem like there's as it doesn't seem like there's a super significant impact of like fundamental frequency or anything. Something that we have noticed is that items do tend to, some items, when they're contrastively accented, do tend to have like pauses after. So we're thinking that might be a potential like confounding factor in the acoustics. But overall, in terms of like low to mid proficiency English speakers, they actually didn't observe the same effects. So we were thinking, so I was thinking that that is a way to kind of contradict that like theory that acoustics would be the only reason why an item is remembered. And then also there have been past studies in past literature where items are like additives and contrastive alternatives are facilitated by the use of contrastive accents in other languages that do use contrastive prosody. So it wouldn't just be acoustics there either because they're facilitating like contrastive alternatives. And then, yeah, as for languages that use like non-contrastive prosody, I'm not sure, which is why we're looking into, at least like for now, we're looking into Cantonese and like the placement of contrast within the sentence to see if that has an impact on whether word slots are remembered differently or whether the contrastive accent like memory is also remembered differently, like language transfer type effects. But for now, we haven't looked into that question yet.
Okay, yeah, thank you very much. Very exciting stuff.
Hi, I'm Jack Yang from the University of Maryland. I'm really interested in your findings, especially with the word slot 1 and word slot 2. So I'm wondering like what reasons you've been considering for explaining the better performance with word slot 1. Was it like in the cases of word slot 2, the prosodically improminent words, like word one, the subject, is sort of like crucial to like participants in coding of the proposition. You know, like if the subject is not like well encoded, then they might not, their memory of the second item that comes will also be like degraded.
Yeah, in terms of like, so you're asking about like the difference in memory between word slot 1 and 2 and like the hypotheses I might have behind that? Right?
Yes.
Okay, so yeah, for the first thing that we considered is like, as I've been mentioning, like the difference in audiovisual processing. So like people have more time to encode items in word slot 1, contrastively accented or not. And so as you can see, like both peaks are relatively high in this fixation graph as well. And the more time spent encoding, the better memory, which we found across all items. And so one thing is just simply the amount of time that people are able to spend encoding a word. And then also, as I mentioned as well, like some of the sentences do end with a contrastively accented word. So perhaps that's a reason is like, you know, or like end with like the the contrastively accented word and then a couple words after. So once again, less time spent encoding, and then there's like the break between stimuli, so they don't have as much time to look at those contrastive visuals as well. And then also, and then we're also thinking of potentially that when contrastive accents are when they occur in the first word slot, there may be some kind of inhibition of presentationally accented words in the second word slot. So that's something that obviously needs further research conducted to see if we can kind of like delve into that and like take that apart a little bit more, but that could be something as well.
Okay, thank you.
Hi, Rachel Yao from UC Santa Cruz. I just wondering, what are your fillers? Because the fillers have better recall than your two critical conditions, and so I'm just curious, what are the fillers like, and especially what are the acoustic characteristics of them, since the results of the fillers are even higher. So that would be an interesting comparison.
Yeah, that's actually something we're also currently going through with the acoustic analysis, because we wanted to have like a more acoustic focus on the follow-up when we're doing Cantonese, just to see if there's any like characteristics, like acoustic characteristics of the stimuli that might cause certain ones to perform better in memory. So far, in terms of the filler versus criticals, we haven't seen any main differences between those two. So that, I'm not sure. I don't think that would be as like credible of a hypothesis there. But then, yeah, as for what our fillers are like, they're just similar. They're the same structure as the critical trials. Although I know that one thing that I found interesting was that a lot of the items that we chose as fillers in this study were ones that had items that were difficult to picture. So like people's names, for instance, or like some countries that we were originally going to use or we did still use pictures, but like they wouldn't be pictures that people would remember as well, like perhaps like the flag of Malaysia. People might not be able to associate that as easily as like cat, right? So a lot of our fillers were like that, and so actually something that I found interesting was that not a main hypothesis, but when I was putting together the stimuli, just a personal hypothesis of mine was that people wouldn't be able to remember those as well anyways. However, clearly the results are so different, like that the fillers are remembered better, and that actually like when contrastive accents occur, it's almost like bringing them up to the level of the fillers as opposed to the presentationals. So that's something I found really interesting. I'm not quite sure why the fillers have such better memory here. Maybe people are better able to associate those uncommon words, like in terms of frequency. Like maybe they know someone from Malaysia, or they have a friend named John, or something like that. And so perhaps that could be a reason. But as of now, I don't know. Do you have any input?
Well, I think the other difference is, I'm the mentor. The other difference is that we put the really short ones as fillers too. It's just a couple of really short items, but maybe those are driving the effect. Maybe we should look at that. That'd be cool.
Yeah.
All right, thank you. Very interesting.
With 30 seconds, I'm going to make a comment. I'm Sarah Brown-Schmidt at Vanderbilt. You might gain inspiration by looking to the memory literature. So Ashley Maxey has a paradigm, and it looks strikingly like a psycholinguistics paradigm, but she doesn't care about us. She's a memory person. No, she's lovely. But so there's a phenomenon that she discovered called recognition-induced forgetting, and the paradigms look like our paradigms. You see two butterflies, they're different, and later you see another butterfly, and seeing the second butterfly suppresses memory for the one that was paired with the original one. It looks just like our material. Yeah, it's wild. I'm like, why aren't you doing psycholinguistics? Anyway, good job. Let's
you.
thank our speaker.